Hello everyone, and welcome to another math tutorial video. And in this video, we're going to talk about how we can measure distances between points that don't share an x and y. And so we're going to do this just like we did before by framing it as an example question. So in this case, we're going to look at a distance between the points 1, 3 and 3, 1. But before we do this, I want to just quickly review something called the Pythagorean theorem. And the reason I want to talk about the Pythagorean theorem is because it's going to come into play here when we start to set up our distance calculation here. So let's go ahead and quickly just describe what is the Pythagorean theorem. Just a quick review. Pythagorean theorem. So the Pythagorean theorem says that for a triangle, actually let's go ahead and draw a triangle here. Let's draw a triangle like, let's draw a triangle with points A, B, and C. And side A, side B, and side C. Right. The Pythagorean theorem says that a squared plus b squared equals c squared. And you'll see here that a, b, and c are the lengths of the sides of this triangle. And again, specifying this is a right triangle. And we'll be talking a lot more about triangles in other videos. But for right now, just keep in mind that we have this nice relationship here between two sides of a triangle and what's called the hypotenuse. So let's go ahead and with this quick review of the Pythagorean theorem here and how it relates two sides to a third, let's go ahead and get back to our question about the distance between points 1, 3 and point 3, 1. So let's quickly go ahead and redo what we've done before, and let's get some terminology out of the way here. So this first point here is going to be P1, or point 1, is 1, 3, which means that our x1 is equal to 1, and our y1 is going to be equal to 3. And you'll remember here, this is from the terminology from the previous videos where we have 2 points. We label one 1, we label the other one 2, and the x's and y's get these little subscripts. So let's go ahead and graph this really quick. So we're going to, just like we've done in the past, we're going to go over 1 because the x value is 1. And then we're going to go up 3 because the y value is 3. And we're going to put our point right here. All right, so this point right here is the point 1, 3. So next, let's talk about the point 3, 1. So point 2 is going to be the point 3, 1, which means our x2 is going to be 3, and our y2 is going to be 1. Now, really quickly, if you remember back to our previous videos, right, we could do some quick. Actually, first let's graph that point. I'm sorry. First, let's graph the point 3, 1. So the x is 3, so we're going to go along the x-axis till we hit 3, and the y value is 1, so we're going to go up to here. So this is the point 3, 1. And just to be clear here, when we're talking about distance, what we're talking about, right, this is our distance that we're talking about. So let's just really quickly review what we've talked about in the past. So we mentioned before that if y2 equaled y1, right, we could do something cool. But if we look here, y1 is 3 and y2 is 1, so that's not the case. They're not equal, so we can't use our x coordinates. And we have a different one where if x2 is equal to x1, right, we could use the difference in the y's. Well, in this case, x1 is 1 and x2 is 3, so they're not equal, so we can't do that either. So we have to come up with a different approach to this problem. What I want to do here is I'm going to use purple to make sure we don't get confused with anything we've already been using. So the way that I want to approach this is I want to sort of keep in mind our end goal here. As I mentioned, we have the Pythagorean theorem in the triangle. Right now we just have this line between 2 points. But what we can do here, and maybe actually I'll make it, maybe I'll use orange actually. All right. We can imagine drawing a dotted, like we can draw an imaginary line down, right, along perpendicular or parallel to the y-axis, perpendicular to the x-axis to the point like that. And we can do the same thing doing this. Right, I'm just drawing straight lines that connect the axis to the point. And you'll see where they intersect, right, we have a new point there. And the coordinates of this point are 1, 1. Right, so again, just to review, we drew a straight line down from the point to the x-axis and over from this point to the y-axis. And where they intersected, where those two lines that we made intersected, we put a new point at 1, 1. Now, hopefully you can see the direct similarities here between what we've created here. I'm actually going to do this in black now. Right, we've essentially created a triangle. Right, I'm just connecting sides here. Right, we've created a triangle. And we now know, and we know that this side here, this is the D that we want. Right? And so we now have a triangle, and we can now directly see how this Pythagorean theorem might help us. So what I want to do is I want to actually stop here for this video. I'm going to pick this up in another video. So if you are confused about how we got to this triangle, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.